Well, what's an odd function? What's an even function? An even function, and this is a basic definition, it is not the full definition, but it would be a function that has only even exponents, like a polynomial. Odd function would have only odd exponents. There are lots of other exceptions to that, but just for that basic idea, let's go with this. An even function like a parabola. For example, x squared plus some constant. So there we go. And we're going to call this a. We'll say that is a. And that is, well, if this is moving forward a, this is moving back a, so negative a. And if I wanted to know the area here, I could represent it like the integral from negative a to a of whatever the function is. But I'm looking at that and I'm saying, well, you know what? You know what? I know what. So do you. This area is equal to this area. I drew it somewhat accurately. So since these two areas are the same, I could do a lot of other things with this. And later on, this might save us some computational trouble if I say, let's just find this area and then double it. So let's write that down. It would be, I left a little gap here on purpose, the area from 0 to a of our function, whatever that even function is. So the area from negative a to a is from 0 to a only doubled. So it's twice that. Even functions, and this is going to be a, again, rough definition. Even functions are symmetric. That's not how you spell it. Symmetric. That's not S-E. Symmetric about or over the y-axis, which means that this area will equal that area. Let me give you another example of an even function that does not have even exponents. It doesn't even have exponents, really, in a polynomial sense. Cosine. Cosine is an even function. Okay, odd functions are symmetric about the, wait for it. You want to say x-axis, don't you? No, they're not. For example, an odd function would be like y equals x to the first power, or y equals x cubed. That's the one I'm going to draw. Let's draw y equals x cubed, which would be something like this, drawn somewhat well. And we'll draw it from negative a to positive a. Negative a to positive a. And we can fill this in here, and this in here. And if I drew it right, then this area would equal that area in a real area, positive area sense. But because this one counts as negative and this one counts as positive, then that's pretty easy. We've seen an example like this. It was this guy right here when we got 0. Area, same areas, but this one is negative, that one is positive. And again, I realize area technically cannot be negative, but the way we compute it made it negative. And that makes a lot of sense from a computational point of view. So this would simply be 0. So never finish this sentence. Symmetric about the, well, it's not the y-axis, it's not the x-axis. Sometimes symmetry is rotational, so it would be symmetric about the origin. And here's what that means. Origin. If I had a little piece of paper, I'm going to try this here on some scrap notes that I have. If I drew this function right here and I went like that, and then I put my pen and rotated, around the origin. Ah, it's not working. No, the demonstration falls apart and no one learns calculus. Ah, there we go. We'd get the exact same thing. So I can rotate it 180 degrees around the origin. There we go. There, now we've learned. Symmetric about the origin. These are two things that are just going to come in handy as we simplify other things. And that is all you need to know about those. But one more thought, by the way. Odd function can be something like sine. Even functions can also be things like absolute value. So there's a lot of opportunities for even and odd functions to exist beyond the realms of polynomial functions.